Right, welcome back, and we're still talking waves and geometric optics. And just before we switch on to geometric optics, I just want to add on this little piece of information there that, remember speed. The normal equation for speed is speed equals distance divided by time, delta x over delta t. This would apply even when we're talking about waves. So in other words, if you're told how far the wave has moved, okay, which is the distance, how far the wave moved, and you are told how long it takes the wave to, took the wave to move that distance, you should be able to find the speed. Okay, all right, so the distance to cover, the time or the period to cover the distance. You should be able, if you have got these two things here, you should be able to use that equation to find your speed. Now, coming to geometric optics, and today specifically looking at how images are formed. So we'll be talking about images a lot. Let's have a look at that. When you are to draw a diagram showing how the image is formed, you need to always have 3 rays. You can have more. Of course, when light shines on me so that you are able to see me, it's millions and billions of light rays that are hitting me and are reflected from me so that you can see this image of Dinyiko. But for us, for convenience, because we are to draw this diagram to show how an image is formed, we make use of 3 rays, okay? And next, we need to know that these images that are formed, the images of the objects that are formed, they can either be real or virtual. The eye is able to see or perceive both types of images, either a real image or a virtual image. Next, let's have a look at the real image. What do we mean when we say this image is real? What are the characteristics that would tell us that this is a real image? 1, this one is formed when rays pass through the object. So the rays have to get into the object and pass, okay, in some way. We're going to show that as we draw the diagram. And this type of object, the real image, this type of image can be projected on a screen. Okay, you can project this, you can enlarge it, you can make it small, things like that. And next, this image is always inverted relative to the object. So if the object was upright like that, the image will be upside down of that. So this will be the image and that will be the object. Okay, that's what it means when they say the object is always inverted, when the real image is inverted. Next, talking about virtual image. An image is virtual when rays do not actually pass through the object. Next, this type of object cannot be projected on the screen, so we can't see it there. We can't use this type of images in movies where we want to watch things happening. Okay. Next, this type of image is always upright in relation to the object. So you can see that actually this is the opposite of a real image. Okay. So virtual image, opposite of a real image, all this always upright in relation to the object. If the object was like that, the image, it may be magnified or smaller, but it will still be upright. Okay, just like that, because it's a virtual image. Next, now having a look at one of the lenses, I only chose the convex lens and show how the object or the image of an object can be formed. We normally use arrows like that to represent our objects. Okay. Now here is a convex lens, and I said you need to at least have 3 rays to show how an image is formed. Now let's have a look at it. This is one of the rays. This is one of them. That's the third one. And this middle one passes through the optical center, and therefore it experiences no refraction. In other words, it changes no direction, okay, because it passed through the optical center. That is the optical center of the lens. Okay. Now this one coming there, this one is parallel to the horizontal plane there, gets there, it's refracted and goes down like that. This one passes through that, it gets to that point, it is refracted and it gets to be parallel to the horizontal. Where the three rays meet, that is where your object is formed. As you can see, there is the object formed there. And you can see that this is inverted. And because this object is inverted, this must be a real image. Okay, real image. And you can see this image is actually of a bigger size than the object, and that should tell us something else. Okay, so it's real, it's inverted, it can be projected on the screen. Rays pass through the object. Okay, if you proceed like that, the rays pass through it. Right, see you in the next section.